Hello again, Algebra 1 students. We're back in Unit 3, Week 2, Family of Functions syllabus. We are on Tier 3, Rays and Continuous Line Characteristics. So let's check off our booklet. And here we are at Rays and Continuous Line Characteristics. So really the difference between a ray and a continuous line is that a ray has an endpoint that stops it at one end, and then on the other end it has an arrow that continues it on forever, just like that. So let's start naming some of the characteristics of these rays. Well, let's look at this one over here. Well, the domain, remember, is all the x values. So the x values are going to come from the x-axis right here. So this ray is going to start all the way over here at negative infinity, because this ray goes on forever by the denotion of this arrow this way. So it's definitely going to start at negative infinity for our domain. But then once it gets over here to 1, 2, 3, 4, 5, 6. At 6, that is this right here, this dot, this endpoint at the end of the ray is the last x value that the ray can be, because there's no x values beyond that. So that domain is going to stop at 6. And if you notice, it has a point there, so 6 is included. So just from previous lessons, whenever anything's ever included, it gets a bracket. And the reason that negative infinity and infinity always have parentheses is because they're moving numbers. So like you can never really capture infinity because it's constantly getting bigger, or negative infinity because it's constantly getting smaller. That's why those always have parentheses. All right, now working with range. Remember, we're going to go from the bottom up is how we read it. Well, again, it's going to go up forever, so it's definitely going to go toward the positive infinity of range. So that's going to be the second part of our range. The first part of our range is where this endpoint is. So if we count down, we have 1, 2, 3, 4, 5, 6, 7. So the first y value on this ray is at -7. So then our range would be -7 to infinity. The point of a ray where it starts is confusingly called the endpoint, and we just have to figure out what it is. Well, it's 6 to the right and down 7. So our endpoint for this ray is 6, 7. Increasing and decreasing interval. Well, this line is never increasing. So increasing interval, we would say none. Remember, our decreasing interval, we only deal with x values on intervals. So our decreasing intervals would be the same as the domain. It's going to decrease from negative infinity to 6 included. And here's a new concept that I'm just now introducing to you. It's called end behavior. And what that means is what happens at the ends of this graph. So let's take a look at the graph, and as x approaches 6, which is the highest positive x value we can get, what is y approaching? Well, the graph is going down, so y is actually approaching -7, the lowest y value that it can get to. Okay, now here comes the fun part. Going the other way, as x approaches negative infinity, so as the graph is going this way, x is going toward this negative infinity, the y is actually approaching this positive infinity. So the end behavior on this ray is that as x approaches 6, y is approaching -7. As x approaches negative infinity, y is approaching infinity. Let's look at this other ray and get an idea of what's going on. Well, I think it's going to be easier if we find the endpoint first. So we go back and it's at -5. And 1, 2, 3, 4, 5, 6, 7, 8. -5, 8 is where our endpoint is. Well, we know then that the very first x value in our domain is going to be at -5, because that's as far as it comes back right here, right? But it's going to go out this way all the way to the x value of infinity, because that graph goes on forever. If you look at our range, it starts, it's going on forever down here. So that means reading from bottom up for range, it's going to start at negative infinity, and then it stops at the highest point, which is 8. And we get that from our endpoint too as well. So our range for this ray is negative infinity to 8. And again, this ray is decreasing because it is slanted like this. Okay, and we learned that back in Tier 1. So we do not have an increasing interval, so we would just write none. And then our decreasing interval starts at the x value, -5, right here, and goes on forever. So it ends at infinity. So it's the same as our domain. Our end behavior is, as x is approaching infinity, so this infinity right here, y is going down toward the y's negative infinity. So as x approaches infinity, y is approaching negative infinity. As x approaches its smallest value, which is -5, the y is approaching its largest value, which is 8. Now let's look at these continuous lines and state off the characteristics real quick that we've learned from the last couple tiers. Well, remember, if a line touches the edge of the graph on the paper, that just means it has implied arrows, so they go on forever. So I'm just going to draw those on. I suggest you draw them on too. My domain on both of these is going to go all the way out here to negative infinity because that line goes all the way forever, all the way to positive infinity. And on this graph, it's going to go negative infinity all the way out to positive infinity. That's on both these graphs because even though this second one is steeper, it still is going to eventually touch every x value. So negative infinity to positive infinity is the domain for both of these. Now let's take a look at the range. Well, again, the range is the y value. Well, the y values start down here at negative infinity and they end up here at positive infinity for both of these graphs. Okay. And if you look, because these graphs go on forever, in addition to the domain, the range is also going to be negative infinity to positive infinity because eventually every single y value will be touched by these continuous lines. Now let's talk our increasing and decreasing interval. Well, this first graph, the line is slanting downward left to right. So that means there is no increasing interval, so we write none. And then the decreasing interval is the entire line, the entire time. So, and remember, intervals are deal with the x values, so they're kind of like the domain. So the entire domain is in the decreasing interval, which is negative infinity to infinity. In the second graph, this graph is not slanting down, it's slanting up going left to right. So that means there is an increasing interval, but there is no decreasing interval. So we can say none for the decreasing interval. Okay, in the increasing interval, again, intervals deal with x values. So you're going to do something similar to the domain, which is negative infinity to positive infinity. And that is the increasing interval. And lastly, let's talk about end behavior of these two lines. Well, in the first line, as x goes toward infinity, so that means this way on the graph, the line's going down. So that means y is going toward negative infinity. Additionally, as x goes toward negative infinity, which is this way on the graph, the line is going up toward y's positive infinity. So as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches negative infinity for this first continuous line. Now looking at our second continuous line, as x approaches infinity, so as we go this way, the graph's going up, so that means y will also approach infinity. And then as x approaches negative infinity, so as we go this way on this graph, this line is going down toward y's negative infinity. So as x approaches negative infinity, y is approaching negative infinity. Good luck on your practice sets.